GATE 2017 ECE Set 1 Question number 44. A 4-bit shift register circuit configured for right shift operation, that is DN goes to A goes to B goes to C goes to D, is shown in the figure. If the present state of the shift register is ABCD equal to 1101, then the number of clock cycles required to reach the state ABCD equal to 1111 is. So for the concepts related to this question, you can refer the following NPTEL course. You can refer lecture 21, name the shift registers, in the course Digital Circuits and Systems, offered by Professor S. Srinivasan from IIT Madras. So briefly, the concepts that are essential to answer this question is that you should know that a shift register is controlled by clock, and every time a shift happens, it happens every clock cycle. So in this case, right shift happens every clock cycle. And it's also important to know the basic logic behavior, especially in this question, the XOR logic is used. Let us now look into the solution part. So let us look clock cycle by clock cycle what happens. In this table, we have the behavior listed clock cycle by clock cycle. So initially, the states are 1101 as given in the question. ABCD is equal to 1101. And we see that D in is got by XORing A and D. So therefore 1 XOR 1 is equal to 0. Therefore Dn becomes 1 at the end of clock cycle 0. Now in clock cycle 1, A goes to B, B goes to C, C goes to D. So therefore we see that B, C, D is 110 and D in is A XOR D. And what is A? A is nothing but the previous Dn. So A is 0 and Dn becomes 0 XOR 0, that is 0. In clock cycle 2, we see that A becomes 0, B becomes 0, C becomes 1, D becomes 1, and Dn is 0 XOR 1, which is 1. In clock cycle 3, A becomes 1, B becomes 0, C becomes 0, D becomes 1, and Dn becomes A XOR D, which is 1 XOR 1, that is 0. In clock cycle 4, A is previous Dn, which is 0, and B becomes 1, C becomes 0, D becomes 0, and Dn is A XOR D, which is 0. In clock cycle 5, A is previous Dn, which is 0, B is 0, C is 1, D is 0, and Dn is 0 XOR 0, which is 0. In clock cycle 6, we see that A is 0, B is 0, C is 0, D is 1, and Dn becomes 0 XOR 1, which is 1. In clock cycle 7, we know that A becomes 1, B becomes 0, C becomes 0, D becomes 0, and Dn is 0 XOR 1, which is 1. In clock cycle 8, A is previous Dn, which is 1, B is 1, C is 0, D is 0, and Dn is 1 XOR 0, which is 1. In clock cycle 9, we see that A is 1, B becomes 1, C becomes 1, D becomes 0, and Dn is 1 XOR 0, which is 1. In clock cycle 10, A becomes 1, B becomes 1, C becomes 1, D becomes 1, and D in becomes 1 XOR 1, which is 0. And this is precisely our required state. ABCD is equal to 1 1 1, and we have achieved this at the end of 10 clock cycles. Therefore the correct answer is 10.